All right, well, you've finished chapter 1, and now we're moving to chapter 4. So chapter 4 discusses ecosystems and communities, and the first section, 4-1, is what is the role of climate? What does climate play in this whole picture? So first we have to define climate. In the atmosphere, temperature, precipitation, and other environmental factors combine to produce both weather and climate. Weather is the day-to-day, and that's where the key is to just determining what the difference between these two definitions are, the day-to-day condition of the Earth's atmosphere at a particular time and place. Climate refers to the average year-to-year conditions of temperature and precipitation in a particular region. So you watch your weather in the morning before school or at night. Charlie Shortino from Channel 15, Gary Canalti from Channel 3, they're all going to, Bob Lindmeyer from 27, they're all going to tell you what the temperature is going to be tomorrow and maybe give you a 5 to 7 day forecast. Climate, that refers to what we're doing here in the state of Wisconsin, in the northern part of the United States. So we know that it's going to be cold in January and February, March, start to warm up a little April, May, get really hot in the summer, June, July, August, start to cool down September, October, and then be very cold November, December. So that would be climate. Climate is caused by, and here's a list, the trapping of heat by the atmosphere, latitude, and of course if we think about the Earth and we think about latitude and longitude, latitude, if we think about the Earth being round, this going across like this is latitude. Going up and down like this are measurements of longitude. So latitude goes across. The transport of heat by wind and ocean currents would be another thing that causes climate. The amount of precipitation, and finally the shape and elevation of land masses. And we'll go into each one of these specifically so you understand the difference between all of them. As we said in the previous chapter when we talked about energy, we said that the energy for everything on Earth comes from the sun. So the energy of incoming sunlight drives the Earth's weather and helps determine what the climate is going to be. So if you remember, sunlight is going to be that key thing that makes all of this happen. The greenhouse effect. We've talked about this probably in previous classes or maybe heard about it on television. The atmosphere is a natural insulating blanket, keeping the Earth's temperatures within a particular livable range. Carbon dioxide, methane, water vapor, and a few other atmospheric gases trap the heat. The gases trap heat energy of sunlight inside the Earth's atmosphere. So that's why the atmosphere is, you think of it as a blanket. When you're sleeping at night and you go under the covers, it keeps your body heat, the blanket keeps your body heat from escaping, and that's why you stay warm when you're all covered up. If these gases were not present, the Earth would be approximately 30 degrees Celsius, and that's going to be one of the key things that you want to remember. It's 30 degrees Celsius, not Fahrenheit, colder without that covering over it, without that atmospheric blanket. So here's a diagram that is also in your textbook and the definition of the greenhouse effect. So the greenhouse effect is when the layer of greenhouse gases retains or keeps that heat in Earth, yet on the other hand, some of it ends up escaping into space. So if you were to look at this diagram, some of the heat that comes in, so sunlight comes in, the atmosphere or the greenhouse gases trap some of the heat, and then others are going to escape. So not all of the heat is retained here. Solar energy enters the atmosphere, converts to heat energy, and then radiates back, and the gases trap the heat inside. The greenhouse effect is basically similar to your car in the summertime, or even your car now. So if all the windows are rolled up, the sunlight comes in through the windows, heats up your car really, 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 really hot because it has no way to escape because of the windows. The windows keep that heat inside your car. So the greenhouse effect is similar to your car heating up when it is in the sunlight. The effect of latitude on climate. Remember, latitude we said was where it's going across instead of up and down. So latitude once again goes this way on the Earth's surface. So due to the Earth being tilted, solar radiation strikes the Earth's surface at an angle that varies throughout each year. And the specific angle of the tilt is going to be 23 degrees. So the Earth actually is not looking like this. It's actually tilted 23 degrees off in this direction. At the equator, the sun is almost directly overhead. And remember, the equator cuts the Earth right in half. So this would be 0 degrees. At the north and south poles, the sun is much lower in the sky for months at a time, because with this having then been tilted, if this was directly north, this is directly south. If we tilt this going over this way, here comes your geometry, the north and the south pole is not always directly overhead. So that's why we vary with our amounts of sunlight, because of the tilt in the Earth. There are 3 main climate zones that exist on Earth. Polar zones are cold areas where the sun's rays strike Earth at a very low angle. So they're located between 66.5 degrees and 90 degrees north and south latitude. So if we had our Earth here, this part is going to be the polar region up here. Temperate zones sit between, and then down here, so the green is going to be your polar. Temperate zones sit between the polar zones and the tropics. And those are temperatures that range from hot to cold. So that's going to be in between this area right here. So the red area is going to be your temperate zones. And finally, your tropical zones. Your tropical zones receive direct or nearly direct sunlight and are always warm. So this area right in here, including the area in the equator, this is your tropical region right between here. And if you think about 23 degrees north and 23 degrees south, those would be the Tropic of Cancer and the Tropic of Capricorn. That's where these lines are located right here, Tropic of Cancer and Tropic of Capricorn. And there is a picture, which I think is in your textbook, showing you where these different breaks are in the latitudes. Heat transport in the biosphere. Unequal heating of the Earth's surface drives wind and ocean currents which transport heat through the biosphere. Winds form because warm air always rises at the equator and cool air sinks at the poles. So this rising and falling of the air causes lots of different temperatures. The upward and downward movement creates air currents or winds that move heat in the atmosphere. So when they talk about cold fronts and warm fronts coming in, when they talk about the weather on television, that's where these different air masses, and they're being blown by the wind, are causing our particular weather. And this diagram here shows all of the different types of currents that are going to happen. And one thing that you really need to remember is if you watch some of these currents, like this one in particular that I just drew, wind cannot go through mountains. Weather cannot go through mountains. So they have to go around, everything has to go around the mountain. Or once they come, if it's coming from one direction to the other direction, it runs into the mountain and it stops. So you can have certain vegetation on one side of the mountain and then different vegetation on the other side of a mountain due to the fact that whatever's blowing cannot go through the mountain. Oceans operate the same way, with cold water at the poles sinking and flowing along the ocean bottom and rising again in warmer regions. Surface water is moved by the wind. Water flow creates currents which transport heat energy. Surface ocean currents warm or cool the air above them, affecting the weather and climate of nearby land masses. So, as you're thinking about all of these different things that are happening with the oceans, with the air currents moving the weather around, the ocean has a big effect on our weather here, even though we're almost smack dab in the middle of the United States. And if you look at the map is going to show you the red indicates, these red arrows, these indicate warm water currents. And then you've got the cold with the blue. So the blue indicates cold water. You'll notice here that the red moves up towards the poles or down towards the poles, and the cold is moving away. So if you think about temperature, with this being the equator, the warm currents move away from the equator, and the cold currents are moving away from the poles. They're coming down this way. And a lot of times you'll have difficult weather in the area where they start to meet. So if you think about the eastern side or the western side of the United States, these beaches are going to be very cold compared to the eastern side of the United States, where this side is going to be very warm. And once again, where they start to meet is where you're going to get a lot of variation and a lot of weather patterns forming. Land masses can interfere with the movement of air masses, and I drew that on the previous diagram. A mountain range can cause a moist air mass to rise, and as this happens, the air mass cools and moisture condenses, forming clouds that bring precipitation. Once the air mass reaches the far side of the mountains, it has lost much of its moisture, resulting in what's called a rain shadow. And that's an area with a dry climate on the far side of the mountain. So once you've written all of these notes down and study the particular picture, if this were the western side of the United States, so this is the western side, and the western side is going to have California and Washington, and that's where all of our weather here in Wisconsin comes from. And so the weather comes across the United States, and then all of a sudden it hits the mountains. And then once it hits the mountains, it stops. And the winds have to go over, and as they go over the top of the mountain, they lose a lot of that moisture because they're dropping it all on this particular side of the mountain. So then as it's coming over, it loses all the moisture, so the other side of the mountain, which is the getting close to the eastern side, so over here, this would be the Dakotas. So North Dakota, South Dakota, they have very flat lands, and it's very arid, meaning arid means dry. That's what arid means, very dry. So over on this side, you're going to have a lot of wet and have more vegetation. And on the other side of the mountain, because it can't go through the mountain, and as it goes over the top, it cools, and then it disappears. You have a very dry side. So our weather, if it's coming straight from the west, we're going to have different weather than if it's coming maybe from the north or up from the south. Because if it's coming from the north, it's not running into those mountains. I hope you were able to understand the different ways that weather and climate come together and how temperature and precipitation play a huge role in weather and climate.